In this lesson, you'll learn everything you need to know for your exam, all about number properties and operations for the 4 basic operations involving integers, rational numbers, and real numbers. Let's jump into the lesson now. In this lesson, we'll begin by understanding integers, which are whole numbers. They include positive numbers and negative numbers, as well as 0. If we draw a number line and we start with 0 in the middle, and we draw a few places in the positive side to the right, and a few places on the negative side on the left, we can see that all of these numbers are integers. Something to be aware of for your exam is that fractions are not integers. Next, let's discuss rational numbers. These are numbers that can be written as a fraction. This means that the test, whether or not to check if a number is a rational number, is to see if it has a ratio or it can be written as a fraction. And we can see inside the word rational has the root word, which is ratio. Now, let's look at some examples. First, is 0.5 a rational number? Well, can you write it as a fraction? Yes, we can. That's 1/2, so it's a rational number. How about the whole number 8? Can we write that as a fraction? 8/1. Therefore, 8 is also a rational number. How about a slightly more tricky decimal, such as 0.6? Can you write this as a fraction? Take a moment and try. Pause the video. All right, in order to convert the decimal 0.6 into a fraction, I'll start by placing a 1 underneath the 6, and I'll write it down below. 0.6, put a 1 right underneath. Step 2, I'm going to multiply both sides by 10. And now we have 6/10. And now we can see that 6/10 is an easy to reduce fraction because 2 goes into both 6 and 10. We're left with 3/5. Because we can write 0.6 as a fraction, it is also a rational number. Now, if our exam standards require us to know about rational numbers, you are definitely going to want to be familiar with irrational numbers. And these are numbers that cannot be written as a fraction. Can you think of any examples of irrational numbers? For example, pi is an irrational number. You might be thinking, but wait a second, 22 divided by 7 is 3.14 and on a little bit, but it's not exactly accurate to pi. And we cannot write pi as a fraction, so pi is an irrational number. In our second example, we have the square root of 2, which we also cannot write as a fraction, so the square root of 2 is also an irrational number. Now, let's take a look at real numbers. Real numbers include both rational and irrational numbers. Let's look at a couple specific examples. The whole number 2 is a real number. The decimal 3.48 is a real number. The fraction 4/5 is a real number. And even pi is also an example of a real number. So the question really is, well, what's not a real number? So then the question is, what's not a real number? Well, imaginary numbers are not real numbers, and infinity is not a real number. Now, your exam may require you to demonstrate a basic understanding of the 4 operations. So now let's look at basic operations with integers. In this section, we'll cover the 4 basic operations, including addition, subtraction, multiplication, and division. Let's recall that a negative plus a positive will give you a negative. And whereas addition, you can flip the numbers and you get the same sum, that's not the case with subtraction. Whereas if we have 7 minus 5, that will give us 2, but if we have 5 minus 7, that will give us negative 2. Whereas with multiplication, a negative times a positive equals a negative, and a negative times a negative equals a positive. And these rules apply with division as well. So if we divide a positive by a negative number, we'll end up with a negative number. And likewise, if we have 2 negatives, so for example, negative 8 divided by negative 4, that will give us positive 2. Now, let's move from integers to operations with rational numbers. Again, we'll be looking at the 4 basic rules of operation, which include addition, subtraction, multiplication, and division. Let's take a problem like 3 over 4 plus 1 over 5. Remember that we can't just add 3 plus 1 equals 4 and 4 plus 5 equals 9, because that's not the way we find the addition or the sum of an addition problem. What we have to do is we need to find common denominators. And to do so, we need to ask ourselves, what's the smallest number that both 4 and 5 go into? And the answer is 20. And then we ask ourselves, how many times does 4 go into 20? That's 5 times. So we take that 5 and we multiply it by the 3 up top, and 3 times 5 is 15. And then let's do the same thing for the second problem. So how many times does 5 go into 20? That's 4. And 4 times 1 is 4. And now that we have common denominators, we can add horizontally. So 15 plus 4 is 19, and the denominator stays the same. Notice here that 19 over 20 cannot be reduced any further. Let's do one more example. This one will have 2 over 7 plus 4 over 7. What do you notice about these fractions? Well, luckily, our denominator is the same. So we can just put that right at the bottom, and this time we can just add horizontally. So 2 plus 4 equals 6, and we're left with 6/7. Let's look at a subtraction problem. If we had, for example, 4 over 5 minus 2 over 7. Just like with our first addition problem, we need to find a common denominator. We need to ask ourselves, 5 and 7 go into which number equally? Well, let's just count by 5s to figure it out and see which of those numbers 7 also goes into. 5, 10, 15, 20, 25, 30, 35. Oh, there we go, 35. So we can scratch out the 5 and the 7 and replace it with a new common denominator of 35. And then we ask ourselves, how many times did 5 go into 35? And that was 7 times. And 7 times 4 is 28. And then we'll do the same thing for the second fraction. How many times does 7 go into 35? That is 5 times. So we take 5 times 2, which is 10, and now we have our common denominator of 35 that can be placed at the bottom, and then we subtract 28 minus 10, which is 18. And notice here that we can't simplify this any further. So let's move on to the second problem. Here we have 5/6 minus 1/3. Now pause the video here and see if you can complete this, and then push play and we'll check it together. All right, so I noticed that our denominators are different, so we need to find a common denominator. However, with this problem, 3 goes into 6, so we don't actually have to change the 6 at all. We just need to make the 3 a 6 and ask ourselves, how many times does 3 go into 6, which is 2 times. So we take 2 times 1, and we're left with 2 at the top. 5 minus 2 is 3. Bring over the 6. Now notice here that we can reduce this fraction from 3/6 to 1/2. Is that what you got too? Great, let's keep going. Next we have multiplication. In a multiplication problem, this one we're going to have 3/5 multiplied by 4/7. Now, what's really nice with multiplication is that you don't need a common denominator in order to solve the problem. You just have to multiply straight over. 3 times 4 is 12, and 5 times 7 is 35. Now take a look at this fraction and ask yourself, can this be reduced any further? Well, the answer is no, so we can move on to the next problem. All right, in this one, we have 2 over 8 multiplied by 3 over 6. Now, take a moment, pause this video, complete this problem, push play, and we'll check it together. All right, so 2 times 3 is 6, and 8 times 6 is 48. Notice here that both of these numbers, 6 and 48, are even, so I know that they can be reduced. They could be reduced by 2, but I'm wondering if they could be reduced any further. Well, they can also be reduced by 3, but I'm still wondering if there's a bigger number. And yes, there is. 6 goes into 6 one time, and 6 goes into 48 8 times. So we're left with the fraction 1 over 8. Next, moving on to our division problem, let's start with this, which is 5 over 7 divided by 2 over 5. Now, in case it's been a while, remember that when you have a division problem with fractions, what you're going to want to do is scratch out the division problem and make it a multiplication problem, and then we're going to flip the second fraction, so we no longer have 2/5, but we actually have 5 halves. All right, now let's go back and solve it. Now we have a multiplication problem, and all we have to do is do 5 times 5, which is 25, and 7 times 2, which is 14. Again, this fraction cannot be reduced any further, except I noticed that we do have an improper fraction, which means that the number on the top, the numerator, is larger than the number on the bottom. So just in case your exam asks you to convert an improper fraction to a mixed number, let's recall how to do this. You ask yourself, how many times does the bottom number go into the top number? In our case, it's 1 time. How many are left over? That would be 11, because 25 minus 14 is 11. And then our denominator stays the same. So you could either write 25 over 14 or 1 and 11/14. Now we have one more problem. I'm going to write this. I want you to try and solve it on your own. For our last problem, we have 4 over 9 divided by 2 over 3. Pause the video, see if you can solve this on your own, and let's check it together. All right, so just like in the first problem, my first step is going to scratch out that division problem and make it a multiplication problem, and then I'm going to flip the second fraction. Now we have 3 halves, and all I have to do to solve this is simply multiply 4 by 3, which is 12, and 9 by 2, which is 18. But notice here that both of these numbers on the top and the bottom are even, and I know that we could divide them by at least 2, so let's start with that. So 12 divided by 2 is 6, 18 divided by 2 is 9, but look here further, both 6 and 9 can be divided by 3, so 6 divided by 3 is 2, and 9 divided by 3 is 3, and we're left with 2/3.